Hello, this is Ms. Nichols, and this is a recap on the section of the test that talks about conservation of mass and systems. So when we're dealing with conservation of mass questions, the first thing you need to understand is the idea of conservation. So the word conservation or conserve means keep the same amount of something. And it's a really important idea in physics because there are a certain number of variables that are conserved in physics and other variables that are not. And the whole focus of this unit was the idea of conservation of mass. So the mass in the universe is the same. We can move it around, break it, change the way it looks, but we're keeping the same amount of stuff in the universe. And that's one really big important idea with physics. So the interesting thing about conservation of mass is that sometimes it's obvious that mass is being conserved. If I took a pencil and broke it in half, you'd expect the mass to be the same on the two halves. And other times it doesn't feel like it is. Like a person, for example, grows and shrinks and loses weight and has a baby, as the case may be for me. But the mass of me changes all the time. And it's hard to kind of imagine that that mass is actually coming from somewhere. So physicists can choose what's called a system to handle different kinds of scenarios that might be relevant. So there's two kinds of systems in physics. One is known as a closed system, and a closed system, basically mass is conserved, which means that it's always going to have the same amount of mass before and after any time. The other kind of system is open, and this is a kind of system where it doesn't look like mass is conserved because it's moving in and out of the system. That doesn't mean we're violating the principle of conservation of mass, because what's actually happening is that mass is going into another system or out of another system. But the mass temporarily is going to be changing in this system. So we'll come back to these in just a minute, but there's a couple really important variables or actually math operators that you should be aware of in this unit. The first one is known as sigma. So that little symbol like that, that funky looking E means sigma, and sigma means that we take some variable and we add it up, add up all values. So sigma money would be add up all the money that you have, or even if you have lots of different little places, your bank account, your wallet, your whatever. Sigma mass would be add up all the mass. So for example, if I had a bag of potato chips and I had 10 chips in there and each one weighs 2 grams, then I would say, so the mass of each is 2 grams or 2 grams. Okay, have, shoot, my pencil changed. Draw. Okay. I have 20 of these things, or 10 or whatever it is that I said. But the sigma mass for the whole bag of chips is going to be 2 grams and 20 chips, which is 40 grams total. So that's something that you should be able to do. The other math operator that you should be aware of is this guy, this triangle, and that triangle means delta, which means how much a variable changed by. And it can be applied to any variable that you want. In this unit, of course, we're usually talking about mass. And so the way you find delta is you think about how much mass you had at the end. So M final minus your initial amount of mass, or the beginning mass. So if you had, for example, if you had a candy bar and it started out with a mass of 100, so MI equals 100 grams, and I took a bite of that thing, and M final is 85 grams, okay? And I asked you, find delta M, right? You think about how much did the mass of this candy bar change by? Well, I ended up with a mass of 85, and I started with a mass of 100. So my change is negative 15 grams. And whenever you're calculating delta, that positive or negative sign in your answer is super important because it tells you something really interesting about this variable. It tells me whether the variable is going up or down or staying the same, right? So if you have a positive delta, that means the mass is increasing. We're going up. And if you have a negative delta, that means the mass is going down, like in this case. And it should make sense because it's going down because I ate a bite of candy bar. If you have mass, delta mass is 0, that means that the mass is not changing. And that is sometimes the case as well. Sorry, this pen is really struggling here. So sometimes when we have a closed system, our mass is not changing. And that is fine as well. Okay, changing. Wow, lovely. Okay, so let's go back to our systems a little bit and we'll see how to apply sigma and delta mass to them. An example of a closed system would be things that change but don't leave the system. So let's talk about something like that pencil that we broke. When you are drawing a picture of a closed system, okay, we're going to draw 2 pictures and we're going to put a solid box around them to indicate that it is closed before and after, and that means that stuff is not getting in and out of those systems. So before we did anything to the pencil, we had a pencil and it looked like this, okay? And there's the lead and whatever, add pencil. Afterwards, I now have 2 pieces of pencil because I broke it in half, okay? You might be given more information about the pencil, like what is the mass of this pencil? Let's say the mass of this pencil is 6 grams. We broke it in half and we know that this guy now has a mass of 2 grams. You should be able to figure out in your own head, what does the mass of this thing have to be? Probably you jumped right away to saying that was 4 grams. And the reason you knew that is because you guys have this like innate understanding of mass being conserved. If I wanted to show this mathematically, I would probably use the sigma operator here to say, what is my total mass in the system? And the answer is 6. There's only one thing in the system. Over here, I know that even though I broke that pencil in half, the mass of the system is still 6 grams. So I have to add those things together to get 6 grams. And if I know one of them is 2 grams, it's like 2 grams plus what equals 6 grams. What must the mass of the other thing be? Well, that's how it has to be 4 grams, which is how I knew that number in the first place. So when you're doing closed systems, sigma mass is always going to be the same because mass in that system is conserved. When you're doing open systems, usually you just draw one box, and we're talking about an object that is changing mass. So the example we gave was the candy bar. So we start with our candy bar, and it has a mass of 100 grams. And what we usually do in our systems is on one side, we write in all the things that are going into the candy bar. And here on this side, we're going to write in all the things that are going out. In our case, we only took something out. What we took out was a bite, which was 15 grams. And we didn't put anything into the candy bar. I could have added sprinkles or added something weird to the candy bar, and that would have changed that as well. But in this case, that bite was coming out of the candy bar, and we had already calculated that delta mass was negative 15 grams in my scenario. Usually we use delta more when we're talking about these open systems because the mass of the object is changing. Okay, well, hopefully this was a little bit of a refresher for you, and you're able to use your notes and use your buddy to have some success on the retest. Good luck.